Lesson 80 is on transformations. Let's review what congruent means. Remember, congruent means same shape and the same size. As you can see here, triangles 1 and 2 are congruent. Now, they don't look congruent maybe because they are in a different setting. Okay, let's talk about what's different about triangles 1 and 2. Triangle 1 is the original. Then it's like there's an imaginary line in between the two triangles, and triangle ABC is flipped over. It's flipped over this line here, and it's like the second triangle is its reflection. We call that a reflection because it's like looking into a mirror. It's flipped. It's the same triangle except it is flipped. We can also change the position by sliding something. Take, for instance, if I take this blue triangle, I just traced over the original triangle, and I slide it on over. It's the same triangle. All I did was slide it to the right slightly. Now, another change of position is rotating. I can rotate or turn something 90 degrees. Let's assume that this vertex is staying right next to F. If I rotate it 90 degrees, you will see that it is in fact the same triangle. So I rotated it, and now I'm on the second triangle. So we have transformations, all of these. The reflection across this black line is a reflection. Remember, we reflect, we look into the mirror, and we see what we see. Then we have the slide, where we are just sliding a triangle. Then we rotated or turned this triangle so that it was in fact on top of triangle 2. We call these all transformations. Transformations have a special name, which we can make a table with. Let's do that. Okay, we've got movement, and we've got the name of it. Okay, we've got 3 of them. The first one's a flip. We call that a reflection. Then we have what's called a slide. We call that a translation. Then, if we turn something, we call that a rotation. I just showed you all 3. Flip, looking into a mirror. Sliding, keeping the same figure, but just sliding something. And then rotating, I can rotate this figure back 90 degrees, and I'm going to have it right there. When we are reflecting figures, remember, across a line, usually if we reflect something on, say, a coordinate plane, remember this is the y-axis and this is the x-axis. If we have, let's say, a square on the left side of the y-axis, we might reflect it to the same position on the other side of the y-axis or the right side of the y-axis. That'll be typical in your homework, is if we're reflecting things, if they ask you to reflect across the y-axis, basically you're taking the original figure and reflecting it exactly on the same points but in a different quadrant. Let's take a look at example 1. Example 1, we are asked to draw this triangle with the points that they've given us and reflect it across the x-axis. The 3 points of this triangle are right here, and we're asked to draw its reflection. Remember, reflection is like looking into a mirror, and we're going to reflect it across the x-axis. Let's first start by plotting our points. The first point is at 4, 3. 4 and up to 3. That's R. Then I have 4 and up to 1. That's S. And the last one is 1 and up to 1. And that's T. Draw your triangle. It's a right triangle. Now, we're asked to reflect it. So, each time that you reflect it, you give the same name to each point, except for you're going to put a little dash or apostrophe by it. What this stands for, it says S prime. The original S is just S. That's this S right here. But as soon as we reflect it, we're going to plot that point, and then we're going to call that S prime. That little dash right here means prime. It just shows that this was the original, and then we flipped it across the x-axis, and that's the new image. Okay, let's get back to reflecting this. So, since S is at 4 and up 1, we're going to go 4 and down 1. So this will be S prime. Now, T, it's over 1 and up 1, so now we're going to go over 1 and down 1, and that's going to become our T prime. R prime, we go over 4 and we go up to 3. 1, 2, 3. So we're going to go over 4 and down 3. 1, 2, 3. And now I have R prime. Draw in my triangle. And now you can see that I have the exact same triangle except for it's reflected across the y-axis. And it's the same distance from the y-axis, both the bottom and the bottom triangle and the top triangle. Now, a translation, remember, from the first slide here today, we said slides a figure to a new position. We don't flip it, we don't rotate it, it just slides. So, that's called a translation. Let's look at example 2. Example 2, rectangle ABCD has these vertices. Draw a rectangle and its image translated to the left 5 units and down 4 units. So, let's first just draw the original rectangle. So, we have A is at 4, 3. So, over to 4, up to 3. That's A. Then, we have B, which is over to 4 and up to 1. C is 1, 1. D is 1 and up to 3. Now, we need to draw in our square. Now we need to move or translate to the left 5 units and down 4. So each point we're actually going to move to the left 5 and down 4. Okay, so take this first point, you're going to count left 5, 1, 2, 3, 4, 5. Then you're going to go down 4 units. 1, 2, 3, 4. This is now A prime. Let's do that with each one. B, you're going to go over 5, 1, 2, 3, 4, 5, and down 1, 2, 3, 4. This is now B prime. We need to move in C and D. Over 4, 1, 2, 3, 4, and down 5 and down 4. 1, 2, 3, 4. This is now C prime. And D over 5, 1, 2, 3, 4, and down 4. 1, 2, 3, 4. If we draw that in, we have the same rectangle. It doesn't look like it here because my grid isn't big enough, so therefore I probably took too big of jumps out here. However, your two figures in your homework, if you use graph paper, should look identical. A rotation, remember from the first slide, turns a figure about a specific point. So, let's take a look at example 3. Here are the coordinates of PQR. We're asked to draw PQR and also draw the image after a counterclockwise rotation of 90 degrees about the origin. That's important because 90 degrees about the origin. The origin is at 0, 0. So we're going to rotate something around that red dot right there. It says, what are the coordinates of the vertices of PQR then? Okay. First things first, we need to draw PQR. So P, go 3 and up to 4. That's P. Q is over to 3 and up to 1. And R, 1, 1. Draw in our triangle. Now, we are asked to rotate this counterclockwise. All I have done here is drawn this black triangle so that I can physically show you how it is going to rotate about this origin. Since we are only rotating it about 90 degrees, notice we are one step away from the y-axis. So when we rotate this 90 degrees would be right over into this second quadrant. We are still going to be one box away from the y-axis. However, it'll be on the left side of the y-axis. So let's rotate this 90 degrees. What's going to happen is we are going to take this black triangle and we're actually just going to rotate it across the y-axis. Right there. Same triangle, it just is rotated. So, if we label our points, our new point right here, this is R prime, this is Q prime, and this is P prime. We are asked to give the coordinates of the new primes. So, if we have P prime, it is at -4, 3. Also, if we have R prime, it is at -1, 1. And Q prime is at -1, 3. We have rotated it, and we've given the coordinates. A dilation is a transformation just like the other three we have talked today. We talked so far about a translation, which is a slide, a rotation, which is a turn, and a reflection, which is a flip. A dilation, however, is a transformation that changes the size of a figure while keeping the same shape. If we reduce or enlarge a figure, it will not be congruent, but it will be similar. Remember, similar means same shape, but different size. So, if this is the original, this would be a reduction, and this would be an enlargement. They all are the same triangle, except for one is smaller, which is the reduction, and one is larger, so we call that an enlargement of the original. Let's take a look at example 4. In example 4, it says, triangle XYZ has vertices at X, Y, and Z. Draw X, Y, and Z in the dilation of the image with the center of the dilation at the origin and with the scale factor of 3. So, we have the following points. We have 1, 1, 2, 1, and 1, 2. So, we notice that each of the new points, X prime, Y prime, and Z prime, all have a scale factor of 3. What that means is each coordinate here is going to be multiplied by 3 because we're enlarging it by a scale factor of 3. So, let's write in our new coordinates. 1 times 1 is 3, 3 times 2 is 6, and 1 times 3 is 3. Same thing here, 1 times 3, 2 times 3. Now I have my new points. Let's graph the first one, then we'll graph X prime, Y prime, and Z prime. X is at 1, 1. Y is at 2, 1. And Z is at 1 and up to 2. Draw in our circle or our triangle. Now, we need to graph X prime, Y prime, and Z prime. We're at 3 and up to 3. Then we're at 6 and up to 3. Then we're at 3 and up to 6. This is X prime, Y prime, and Z prime. Same exact triangle, it's just one's larger than the other. this concludes our lesson on transformations. Remember, the 4 transformations we talked about today were reflection, rotation, translation, and dilation. For your practice, you can find it on page 555. I would like you to do A, B, and D.